Good morning, or good afternoon, or even good evening for all our guests around the world that have decided to join this webinar for the Nevion initiative at home with the Nevion architect. My name is Cosimo Gualano, and I'm the Director of Marketing Operation in Nevion, and I'm based in Norway, and I will help you through today's webinar. We are all glad to see that so many people have taken and decided to join the session today. That is a series of activity that Nevion has put together to provide you as much information as you should have possibly received if you were attending the real NAB this year. Most of all, I hope you're all doing well during these difficult times. Andy Rayner is a Nevion Chief Technologist, will be presenting today's webinar. So here comes the time where I give the floor to Andy Rayner to start the presentations for today. Thank you.
Thank you, Cosimo. Good morning, afternoon, evening, wherever you are. I'm just going to share this, just double checking that we've got the screen up there. Looks like that's all well and good. So yeah, nice to be with you today at the kickoff of our virtual NAB run within Nevion. Do stay tuned over the next few weeks. There's lots of exciting stuff coming up online and also meetings, and I'll come on to that in a little bit. For those of you that don't know me, I want to tell you where I'm speaking to you from. If you look at my map of the UK there, on the right southeast side there, on the bottom right hand side, right near the sea, in this place called Felixstowe, about 1 mile inland from the sea is where I'm speaking to you from. And I want you to know, last weekend I got round to mowing the lawn. And the sun has been shining beautifully for the last few days. I trust it's been good weather where you are. So this is the first in the series of At Home with the Architects for our virtual NAB, and I'm going to be talking about distributed production, how we actually join together 2110 facilities, and sharing you some of the wisdom and knowledge we've gained in that space. So you can't have a meeting without a few notices to start. So two quick notices. First of all, this time next Friday, in fact, both of the seminar slot times on the Friday, the one earlier and this one, I'm doing another webinar called the Move to Full Software Virtualization. So that's a bit of a future looking one about the whole broadcast chain going completely virtual and what needs to happen in the industry, in standards and so on, to actually get us to that point. So that's next Friday. Also a reminder, we're getting quite a busy diary, I think, already with all of our sales team and architects, etc., for the at-home and virtual NAB meetings with all of our customers and friends across the world. If you haven't yet booked one, please do get in touch with your sales channel in Nevion, or if you can't get hold of them, just send me an email and I'll happily get you in touch. So those are the two official notices I think I was supposed to give you at the head of this session. Right, let's dive in. So one thing I just want to reiterate, and I know many of you that have heard us speaking at any of our events before, our webinars, our pre-NAB and pre-IBC events, and wherever else we've met up with you, we are a company that's absolutely passionate about standards. So we invest heavily in working together with other people across the industry, both our competitors and key customers, to actually help bring to fruition and to actually make as good as possible all of the standards that are used across the industry. And as such, we sit and are heavily involved in all 5 of these standards bodies that are outlined on this picture here, not only in helping to define standards, but also working out how we actually prove them and how we actually get to the point of actually the customer and the end users having confidence of what's happening. And obviously, I in my role do a fair bit of advocacy in terms of telling people about these standards. And a little bit more to follow on that in a couple of minutes. Just wanted to say that obviously we've been, with the passion we've got for this, Virtuoso, which is our software defined media node, is something that we've been very proud to actually have as part of the tested events that have been run by the JTNM. It's involved lots of what I would call kind of independent, high level customers and technical organizations, things like people like the EBU, the BBC, CBC, and so on, who have actually been helping to operate these vendor neutral events to actually prove that the industry has actually got the capability that we claim we have. And we've been proud that our equipment has been in the forefront of those testings as we've gone, and we've been accruing the different badges that have been coming out of that over the last couple of years, which has been great. So before we kind of dive into facility federation, I thought it was worth having just a handful of minutes on a revision of the standards that are involved in IP production and where they're at, and kind of give you a little bit of an update as well as to where we've got to with those standards and what's been happening in recent months as well. So there are two key sets of standards and recommendations that form what we're using for IP production. First of all, there's the SMPTE 2110 suite, which basically is the first two rows of circles on my picture here. And then there's the NMOS control specifications, which is that bottom row of circles, which I'll come to just in a couple of minutes time. So just to kind of give you a very quick, succinct recap on the SMPTE standards and where they sit and what they're doing. That first row there, the -10, 20, 30, 31, 40, and -21 along there. Oh, by the way, I forgot to say, I've got a very nice cup of tea here, and if you'll excuse me, I will occasionally take a sip to keep me going through this webinar. So that first set of standards, or that first swathe along the top row, is what we started with and was matured from the VSF work on TR03. And basically, -10 defines system parameterization, defines the overall timing, the overall behavior of how we actually do things and how the essences are constructed. Then we've got some specific ones. The video one, -20, defines uncompressed video at a variety of bit depth, spatial, and temporal resolutions. The audio -30 defines effectively 24-bit AES audio being carried transparently. The -31 carries all of the bits of the AES3 signal, so that includes all of the other bits that are nominally non-audio, because some specific compressed audio and other transports that need to be carried actually consume more than the 24 bits to actually achieve what they need to. So that's the transparent 32-bit, the -31. Then probably the main piece of work that was done to actually get this standards up and running was done by Thomas Edwards, now with Disney in the US, who defined the recommendation that we're using for the -40, which is the ancillary data mapping. This is all of that stuff that typically you would traditionally have conceived as being in the VBI or HBI of a video signal that we're actually carrying as a separate flow now. And then the -21, which is all about timing. As is obvious from what I've already said, but I'll just say it anyway, the key thing about this suite is it's all about carrying the different media flows as different elementary streams. And the reason that's important, or different essence streams, should I say, the reason that's important is that means every piece of equipment in the broadcast production chain, be that virtual or physical, that needs to consume or process one of those elements only has to actually take the actual thing it needs. So gone are the days when we had to have an SDI de-embedder to pull the audio out for us to actually then do what we wanted with the audio, then shove it back in as an embedded element back into the composite video signal. We don't need to do that anymore. Obviously, timing is all important, and we're going to come back to that a few times during this webinar. But the important thing, once you fragment something into multiple essences of the individual media flows, is very important then that you actually know the timing so you can actually reconcile them downstream. So that's the top row. The second row is newer stuff that's emerged since the original part of the suite. -22, we've actually, within Nevion, started to use significantly in the last 9 months. I have to admit, when it was proposed maybe a couple of years ago as part of the suite, I was a tad skeptical because I felt that introducing a compressed video essence within the suite was something that wasn't necessary. But actually, as this very seminar is talking about federation and distributed production between different locations, suddenly the requirement or the need for some form of video compression over wide area connectivity, be that national or especially international, becomes important. So we're going to talk about that more in a minute on the Dash 22. Dash 23 was put into place to actually allow things that actually need higher frame rates to actually run with Dash 20. So actually, effectively, it's multi-part video. So if you've got a high frame rate signal, such as the main application, of course, is slow-mo, then those devices tend to use this because it allows them to actually concatenate, if you like, multiple Dash 20 flows to actually create the multi-part video. You see the SD video there, and you know, it's a bit of possibly a backwards looking thing, but it's very necessary in the suite, because obviously in the suite it was predominantly HD and upwards focused, and although obviously the video essences very capably carry uncompressed SD as well, there were a few nuances. Those of you that are as old as I am, or even older, know about the nuances in the analog SD world of when does the line actually start, how wide is an active line, and so on. Lots of different bits. And what this is doing, which is very much work in progress at the moment, Dash 24, attempts to capture and define those uncertain and not yet fully defined elements, so we have full compatibility, which is what this is all about. Moving on to something else that's not yet fruition, but you need to be aware of it, up and coming, is the Dash 41 and 42. This is very specifically about fast signaling. Those of you that are aware of the way the 2110 ecosystem works is basically senders create what we call an SDP, which is if you like, a textural description of what they represent as a source. Which is all very fine to be consumed, but the way that updates and the way that process works is not that fast in terms of what we're used to in terms of video frames and fast response downstream. So to allow downstream equipment to become savvy to changes in an individual essence flow, then the fast metadata stream concept is it'll be probably just one packet that's sent right at the head of the first frame where something may have changed. So if the video standards changed, or the resolution's changed, or maybe the audio channel width has changed, whatever that change is, it can be signaled immediately. So downstream the kit doesn't have to gradually resynchronize and rediscover new things. It can be done instantly. So that's work in progress. I'm reckoning that's probably going to take through the rest of this year to come to fruition. And then on the right-hand side of the second row down is 2022-8. Those of you that remember 2022-6, which is still in use for a lot of wide area connectivity globally and certainly nationally in the UK. I call it composite, not because it has a subcarrier, but because it's effectively a digitized SDI signal. It's still got all the ancillary data and all of the audio embedded in there. And the specific change between 2022-6 and 2022-8 is the inclusion of the RTP timestamp. So it can become part of the family because it's actually got the same timing information. So we can reconcile a Dash 8 stream in the same way that we can reconcile the elementary streams that we've covered already. So that's what I call the data plane, all of the media essences, how they're carried. We then come on to this bottom row, which is all about the control plane. Now, some may argue we should have tackled and got this element of the whole ecosystem underway a bit faster than we did as an industry, but we've made good progress, and we're now in the last year starting to see real systems that are actually coming out that are fully utilizing the NMOS control plane to actually allow devices to register themselves, to be discovered, and then to allow connectivity to happen automatically. And what we're really trying to get to with this control plane stuff is effectively a plug and play equivalent. So whereas you may plug an SDI camera in, that SDI signal is instantly available. There's a little bit more behind it when you've actually got all of the elements that are associated with an IP environment. So we want to try and make it as plug and play and as end user friendly as possible. And that's what this is all about. You'll see the various extra numbers that have gone up there. There's all things about, how a system initializes when you first start. How we actually carry tally information and other event-based information like fader positions on a mixing desk and things like that. And specifically on the ISO8 for the audio channel mapping, another nuance, which is how we actually shuffle or manipulate audio when you've got multiple channels within a single essence. So all of those bits. And last but certainly not least, and we'll come on to this again in a minute, is the security suite, of which the BCP 003-0, and there's a few different ones there. The all-important element, which arguably again should probably have a higher elevation than I've given it in this slide, but it's all about making sure what happens is done in a secure manner, leveraging best practice from the IT industry and making sure that's actually put into place here in the way we do stuff, especially important in the control plane. So that's my very quick revision of where we've got to on this suite. Just to say, on the top row there, we have been doing some revisions, 1 year revisions of some of the, or nominally 1 year revisions of some of these initial standards already. So the -10, 20, 30 and 40 and 21, we've all been working through within the standards committee in the last few months, trying to actually maybe make some nuanced changes that are basically to improve things or where we've missed things out and didn't quite define things robustly enough in the first place. And that's everything from some system timing stuff in -10, which I'll come on to a bit later on, and also on -21 timing, not only the specification of timing, but also try to accurately define how we actually monitor it as well. Okay, so there you go. That's the whole overview there. Just dwelling back onto the -22, the compressed video essence that we talked about. We have found this in the last year, basically, since we've started deploying it, to become an invaluable component in the toolkit to solve specifically distributed production and the federating of different facilities over long distance, because the cost of connectivity on a wide area network is much more significant compared with the almost zero cost of the infrastructure within a campus. So it's become very important and apparent that it's important to be able to do some lightweight compression, some what I call mezzanine compression to video flows in many of these instances, especially if we're going internationally. JPEG XS, you've probably heard about it being talked about a lot. We actually did our first deployment last summer. We were very excitedly, I think, the first to market globally with that. And one of the key things about it is it's a very, very low latency. So if you think about the propagation time in fiber of a signal, it's roughly each millisecond is about a 200-kilometer distance of traveling the speed of light in fiber. This XS, the compression and decompression itself, only consumes less than 1 millisecond. So if you think about the whole of this with respect to wide area connectivity, this means that the compression we're applying here and the decompression is negligible in the scheme of things, which is an incredibly important thing. I've put there typically up to 10-to-1 compression. Depends exactly on the application, but probably typically between 8-to-1 and 10-to-1 is the rates that people are running this to get that mezzanine compression. And obviously that saves a massive amount of bandwidth in the wide area connectivity. So thinking about the systems and where we're going and what we're doing with them. So I've been talking very specifically in the last few minutes about effectively IP LAN, facility IP. All that suite of standards has preliminarily been developed for a facility, a campus environment, to actually make a facility work in an all IP manner. Now, obviously, the heritage that a lot of the Nevion company has, including myself, coming from a BT, a telco in a previous life, has been a lot to do with IP WAN, and IP WAN has been maturing for a lot longer than IP LAN. We've actually been, doing solutions on WAN with IP for 20 years now, whereas the LAN probably realistically is 5 years old in terms of doing serious solutions with IP in the LAN. I know some of the audio guys got there a bit ahead of that, but certainly from a whole video systems perspective, I think that's where we're at. But what we're really excited now is seeing these two things come together, because is when they come together and we actually start to leverage the benefit of an IP interconnect between IP facilities. That's when we get real benefit. More of that in a minute as we actually move through this. Our VP of Marketing produced this excellent, very simple but very succinct and detailed slide here, which actually describes the different areas that I think we are certainly covering as a company, and the different areas that we are looking at and trying to cover in what we're explaining to you in this session today. So we've kind of got the 4 areas here. So just looking first at those light green rounded rectangles, the facilities, that's what I've been really talking to you about. The concept is that's a campus with a number of studio floors, galleries, production areas, whatever, and that needs to have a whole ecosystem of all of the elements that are needed for producing a whole production chain within IP. What we then have in the red over on the left, obviously, is an OB van, which, if you can think of it, is probably a very small facility. It has to have a large elements of the all of the things that are needed in a facility, but just on a smaller scale. So a very small but self-contained OB van. We then have that on the left-hand side, in the blue rounded rectangle, remote production. Very much what this is all about is actually doing what you would call typically REMI or at-home production. This is very much about having a leaner outfit that's out in the field with the OB or the event, and actually having more equipment and people specifically back at home in the gallery, actually running the production from at home. And that's obviously where we actually start to see some significant benefits of the flexibility of the IP system. And then last but certainly not least is distributed production, where actually what we're even starting to see now, and this has really only been happening, I would say, in the last 18 to 24 months across the world, we're actually starting to see facilities actually working not only autonomously, but actually sharing together. And that's when we get real benefit, and more of that in a minute. So moving on, I think one observation is we've moved from what I call the early adopters in the industry to the IP facility becoming business as usual. The standards have matured, the equipment's matured, everything right through to the test equipment at the far end. The whole end-to-end system has matured to the point where we can roll these things out. We've got design templates. We know the architectures we need to do, and we're rolling out, and we're seeing a significant uptake, both in terms of the number of and the size of facilities that are being delivered now. Talking of size, one of the astounding things is just how quickly that scale is building up. I look back maybe just 3 years ago, where we were actually seeing something to the order of up to 10,000 connections as being kind of almost a stretch target in terms of a system design. 3 years on, we've now exceeded 100,000 in that number of flows. So that's actually a really significant uplift that we've got to just in a 3-year time, over a decade, or in terms of the sheer number of flows that we're dealing with. And a lot of that's driven obviously by the way, as we move into this essence-based world where each individual media element has its separate flow, that by necessity means you actually have several flows where you would have had one traditional SDI with everything embedded in it. But still, even to that, we're seeing these significant numbers. The other thing that has become abundantly apparent to us as we've been doing these solutions and delivering them is that the technology abstraction from everyone involved is absolutely fundamental. No human can kind of handle working out how to address and sort out 100,000 plus flows. So technology abstraction is key, and one of the key things we've been working on with Video iPath, which is our orchestration software toolkit, is making sure that is able to abstract both the engineers, the operators, and the end users from needing to understand and be in the minutiae of the detail of things like IP address configuration. You can give Video iPath a rule set, and it can actually run that. And that's become abundantly important for all of these large scale networks, as it also is for smaller scale networks as well. So we've talked in the last couple of slides a little bit about what's the benefit of IP. If we jump back to some of the, what I would say, the early deployments that we were putting into place, maybe in the early years of the facility IP, maybe 5 years ago, you know, we were basically replacing SDI with IP in terms of connectivity, which is great. And for technology people like me, that's an exciting thing to do, but it actually probably wasn't benefiting the end user much, either from a cost base or a flexibility base. But now with the stuff that you're seeing that we've been talking about, where we've actually got different facilities that are interconnected together because we're connecting in IP in the wide area and the local area, we're actually able to share lots of things. We're able to share physical resources, be that physical devices, be that virtual device and virtual compute capacity. We're able to share facilities, physical stuff like studio floors and galleries dynamically. And more importantly, in all of them, we're actually able to share people and share people out in a more efficient way as well. So this whole shared resource thing, whatever kind of resource we're talking about, is when we really start to leverage benefit. And that has really been starting to come into place literally in the last 2 years, as we're starting to see these interconnected systems where we can do at-home production, distributed production, mesh production, REMI, whatever you want to call it. All of this stuff is now starting to give us and give the end user not only additional flexibility, but real cost savings and benefits. So scalability is something that's a key thing that we're seeing with an ever increasing drive. I talked about the sheer number of connections just a couple of minutes ago. We've got other things that need to scale as well. So the capacity of the infrastructure we're putting in is scaling, driven by increasing resolution. So we've got obviously most solutions that are going in are at least HD. A lot of them are going in natively as at least as UHD capable and dimension for UHD, even if they're not running UHD yet. Obviously, UHD necessitates high dynamic range as part of that, and there is a desire moving forward for increasing bit depth to further improve that. I personally have a passion that we actually introduce high frame rate. To me personally, that's more important than increasing spatial resolution, but that's all for another topic. But you know, all of that requires and drives more bandwidth. So that's a very important drive to scale, the scaling of the fabric, the aggregate data rate that we're using within facilities. We're also seeing just more and more signals are being used, not just because we've gone to essences, to the individual media components, but also as we can do more, you know, producers and the creatives have an insatiable appetite for consuming more. We've seen that in so many situations in the last couple of years. You know, if there's the offer of being able to have more stuff available, people will take it. And then very lastly, but obviously not leastly for this presentation, distributed production, because that is actually requiring even more scale, because we're actually having to scale to not only to support what we've got within our facility, but if we're doing some kind of federation sharing, we need to be able to control, share resources, have that connectivity that's aware of that. So we're scaling outside of our, you know, our campus ecosystem, if you like. All very important. This is a concept slide of a deployment, the architecture of a deployment that we've been doing in the last year, which I think is an important one to look at, because it kind of addresses some of those things that I've been talking to in the last few minutes. So first of all, the concept of shared resources, basically this solution has 2 large data centers, geographically diverse, where all of the stuff is. So all of that virtual and physical resource that's needed, production resource, is all in those 2 locations, and that is shared by what I would call thin clients in the remote locations. So they don't need to have that much in terms of the high processing capabilities. They can actually leverage those resources from our 2 big data centers that have been deployed. So we start to see different people in different locations being able to use shared resources and obviously share their capabilities in this dynamic dynamically configurable environment for many locations, not just nationally, but internationally. This is also demonstrating, and we'll come on to this more a bit later on in this seminar, the concept of interconnecting orchestration systems and having some federation, because there's a very definite requirement, and we'll reiterate this later as well, that those two locations are able to run fully autonomously and independently and fully effectively, but at the same time there needs to be some resource sharing. So you'll see that vertical green arrow there on the left, indicating the resource sharing and the secure communication to allow the federation of some elements of control and signals between that. We'll talk more about that and the different ways that's been achieved as we move through the next few minutes. So in terms of distributed production, just coming back to, if you like, a few of the fundamentals, there are three main reasons why we want to do some of the stuff that we've been talking about in the earlier pictures there. First of all is the, if you like, the classic remote production, as I say, a lean OB environment, a lean event environment, at-home gallery, have as much of the equipment, processing and people back at home. And that's the event remote production scenario. We then have two different scenarios where we're sharing typically between facilities. One is within a company. So a company is, sharing its resources, and we've seen that with some of the solutions we've deployed in the last couple of years, where where one studio or gallery or set of studios and galleries is used less at weekends, more in the week, and so on. So we can actually have some very useful sharing of resources and equipment, such as replay equipment, graphics, anything you like that's part of that broadcast chain. And then the last one, intercompany facilities connectivity. This is all about interconnecting, different companies who may obviously be potentially competitors as well. So just back to that security point as well, the way we do this stuff needs to be done in a very secure manner. Worth saying that, Video iPath, we have been, which is our control and orchestration tool, we've actually been deploying both in campus infrastructure and in wide area infrastructure for a long time, and now we're starting to leverage benefit of actually us brokering and sharing resources between locations as well. And as I've put at the bottom there, there's two levels of challenge. One is the actual connectivity of the actual flows themselves, what I call the data plane, and then there's the control plane, which is all about if you want to share a resource and make it as plug and play as possible within the other facility, then some of those challenges come out, and we're going to address that again shortly. Just want to say, not only are we talking about campus to campus, but as we've already indicated, we're also talking about maybe a campus to a truck or vice versa, or even truck to truck if you're doing some kind of shared or meshed production, remote production. And then moving forwards, and we're really just starting to dip into this, I think, within 2020, in anger, I would say, within the industry, in the deployments we're looking at, one end of that system could be cloud. So we're not necessarily thinking we're connecting a facility to a facility or a facility to a truck. We could be connecting a truck or a facility into a cloud. So all of the stuff about the data plane and the control plane still applies as we go into the cloud. I mentioned security briefly earlier on. It's a vitally important element of everything we're about. Security not only of the data itself, but possibly even more importantly, security of the control plane. Everything about making sure that the way everything is done in a secure manner. And there's a lot of best practice in the IT industry which we can leverage there, and I think we're starting to do that very effectively now. But this, it should be the first and last thing that is checked in any architecture design, that the security elements are addressed. So, moving on to one of my favorite topics, which is time. So this is an example of a concept of how we distribute time within a new facility. This isn't supposed to be an exact, this is how you do it. It's just a concept before anyone rings me up and tells me I've got something wrong. But the concept of a true distribution of timing using different types of switch to actually give us a scalable distribution to many, typically in a large facility, many thousands of end devices that need to actually know about time. So gone are the days, well, in new deployments, gone are the days of black burst distribution. It's all about distributing over IP, the PTP. And it has to scale, as I've already alluded to. It has to be secure. There have been some challenges in making sure that the PTP distribution is fully secure. So making sure all of those standard PTP-based stuff works, but also any other resilience architectures actually work there. And then dependability, making sure that everything in the system knows that what it's seeing and what it thinks is time, accurate time, truly is accurate time. There's a whole seminar's worth here, so I'm not going to say any more on that at the moment, but we can unpack that in another session later on. So that's all about time within the facility. What we're now looking at is timing between facilities, and I want to jump you back in time a long way, I think somewhere around 180 years to 1840. So this was when, certainly in the UK, we started to need to coordinate time and have common time in different locations. So this is a timetable, one of the first timetables that's published once we had coordinated railway time across the UK. And you'll obviously see the synergy here between what we're talking about here, because it was very important that each train station actually was running to the same time schedule. And the analogy that we have here is we actually have very accurate and absolute time that we can gather from a number of ways at a location. So typically, most facilities run some kind of GNSS, something like GPS, that allows their grandmasters that distribute that PTP in the tree I showed you previously to actually know about time. There's also time as a service, which is actually another way of getting on the wire time delivered to you. But time is important, and it's very important that each of the facilities we're federating or sharing production with are actually running with the same frequency and the same phase. All of that's defined in SMPTE 2059, which defines how all of the actual timing of every video standard and every audio sample rate ties up with the epoch back in 1970, and how you actually calculate the exact moment in the frame you're at given a specific absolute time. Goes without saying, obviously, if we've got wide area interconnect, there's going to be some kind of fixed latency between facilities just in the delivery of those media essences. That needs to be accommodated, and more on that in a minute. What I'm showing you here is a picture which is already the concept of what I call the media edge. So this is all about what needs to happen, or the toolkit of things that may need to happen on the edge of a facility as we go from what I've shown you on the left there, our green side, to our red side, which is the big wide world where we're going to be effectively then interconnecting into another facility or a truck or the cloud or whatever. So just whistling through these, obviously we've talked about PTP timing within a facility. That obviously scales, it works very well, but typically our recommendation in designs is that the PTP timing is kept within a campus infrastructure. We don't try in general to long haul PTP time, because just like my railway example, if we're all referencing an absolute standard at our different locations, then we don't need to try and long haul accurate time. But there are situations where we may have alternative timing domains coming into a facility which we need to synchronize. And also, as I mentioned just a few seconds ago, we need to accommodate a phase shift as we're coming inbound because of just the offset of a long haul connectivity, which may be typically anything up to a video frame's worth of time delay that's incurred in transit. I'm going to come back to the device discovery and control in a minute, but suffice it to say, the discovery and control stuff that happens within a facility needs to be secure and work within that facility. Once we're going out and sharing resources, that discovery and control needs and registration needs to be very carefully restricted and governed. Typically, the third one down on the left, we'll have an IP addressing scheme that's arbitrated by the controller, typically in our deployments video iPath within a facility. Obviously, if we're going off campus, that may well need to be address translated into a different set of IP addresses there. Almost always within a facility, we have uncompressed media essences, both the audio and the video. As I've alluded to already in several deployments, especially international, then the use of compression specifically for the video and higher both spatial and temporal rate video is quite common. So we need to potentially to uncompress as we come into this border here. And then protection termination. By that, I'm talking about reconciling the 2022-7, which we lovingly call SIPs within Nevion, but it's that RTP merge, spatial diversity and merge technology, and also on the wired area network, which I'll come to briefly in a minute, potentially FEC as well. So all of those things are things that may well need to happen on the edge of a facility. And as you can see, I've put our Virtuoso Media node there because these capabilities are the kind of things that can be served from our Virtuoso Media node, and we'd be very happy to talk to you about that. I won't dwell on this diagram because it's kind of saying the same thing as the last diagram, but in a slightly different way. On the left-hand side, you'll see everything about the facility, the essences, the control protocols, the timing information that's running, and any other data. And on the right-hand side, you can see what we've aggregated and what we're doing as we're actually going into the WAN world, if you like. Now, we've been doing a lot of work, obviously, to actually provide these media facility edge capabilities, and also to look at some of the federation of control between different video iPath ecosystems that are running in different locations. But what we've been working with, and specifically it's been one of the things I've been overseeing in the last year or so, is some standards work to look at how we actually standardize and have some agreed interoperable behaviors for transporting 2110 over WAN. And I'm just going to spend the next 5 minutes giving you a quick resume of those and unpacking things. So first of all, I mentioned it just a couple of minutes ago, 2022-7, spatial diversity, RTP merge. So we merge packets at the RTP layer at the destination. That's something, that standard was actually tweaked just over a year ago to actually allow it to apply inherently to any of these essence-based flows. So that we kind of get that for free. It's out the tin, it's already defined, so we can use that for our spatial diversity and that 1+1 resilience if we have the bandwidth available to actually allow us to do that. If you don't have the bandwidth, or if you want to go belts and braces, we also have defined in this draft standard, we're going to use a subset of the existing 2022-5 FEC matrix, which allows us to actually provide additional error correction should we not either have enough bandwidth to run the 2022-7, or should we actually have connectivity which we think is not good enough to not run without FEC. If that is the case, I would say it's probably worth checking your connectivity out, but this is available as part of this toolkit. We then have defined or proposed a draft of a trunking scheme, and this is basically taking, if you like, aggregating lots of these essences together, multiple videos and audios, if you like, to put them into a trunk to carry. And there's two reasons we may want to do that. One is because we don't want each of them to be subject to potential differential routing within the service provider world in the WAN. So if we can aggregate them together in a trunk, that means they're going to be carried and routed in the same way, subject to the same routing, same latencies, etc. The other thing is, just be aware that there are very, very significant different bit rates we're talking about here. A UHD video essence is the order of 10 gigabits per second. An individual mono audio would be somewhat sub 1 megabit per second. So we're already starting to see four decades worth of difference in the bit rate there, and the -40, the ancillary, could be even another decade lower or less in terms of bit rate. So we've got massively different rates. That in itself obviously isn't an issue, but as soon as we start trying to apply things like FEC, then because that's packet period dependent, we could potentially risk incurring very significantly different latencies in transit to these different bit rates. So if we actually put them all together and aggregate them in a trunk, and then I have to say this very carefully, FEC the trunk rather than the individual essence, then what we actually do, we're subjecting each of them to a very small but identical latency. So there's a lot of value there. I won't dwell on this slide. This is just a slide that explains the wrap. You'll be able to see this on the slide deck afterwards. So this explains the draft trunking encapsulation that we're proposing to be part of the toolkit. We've also had requirements from some users that we actually want to protect in the same slipless way with the -7 other types of data. So that's all included as part of the standard. Just coming on to time very briefly, I think it's important just to remind everybody this. This is my pet topic. I love to talk about time. And basically, as you may well be aware, part of the SMPTE 2110 standard is actually timestamping the origin of both like the video and the audio and any other information that's source metadata or tally buttons, whatever is happening at whatever moment in time, the origination time of that happening is captured. And we put a reduced size version of the PTP timestamp into the RTP timestamp within the packet. That allows us to carry that. So that's all well and good. What we're then seeing in some of the early deployments, certainly from some systems that are being deployed, is that as soon as we get to the first piece of equipment in the chain, that origination time is being lost because that equipment is generating a new and set different timestamp on its egress of the processing it's done, which doesn't relate to the origin time. One of the deltas, one of the changes that we've made to the -10 in the 2110 suite in the 1-year review that we're just literally sewing up and completing at the moment, is actually trying to encourage people to actually honor this origination time. So basically, if you have a piece of equipment in the chain that's creating a process and it takes n frames, then what it makes sure is that frame n still has timestamp x on its egress, the same timestamp that was associated with frame n when it came in. That means when we get to use time on the right hand of this diagram here, we actually can reconcile them automatically because each of the essences, whatever path they have traversed through the production environment, is actually able to be automatically aligned because we can use that timing information to reconcile them. The reason I'm specifically talking about this here is that's very important when we're federating, because when we're going off campus, we want to prescribe that those essences have been aligned, or if we haven't aligned them, at the very minimum, the RTP timestamps of the relevant different media essences that we've got the timestamp represents the delta in time between them, such that when they hit the other facility, they can be reconciled. So that's very, very important. Again, love to unpack that a bit later on, or on another time, not later on, don't worry, not much more to go. Compression, I don't think I need to dwell on that. It's fair to say we've already been talking about that. The two compressions we've kind of defined as candidates here are what I call both mezzanine compressions. There's XS, which I've already described in detail earlier on in the seminar, and that's, I think, going to become the choice, the de facto choice here. There's also obviously the Sterling work which VSF have done on TR01, which is a standard for JPEG 2000, which is again a mezzanine-based wavelet compression, and there's also a lower latency version of that which was standardized a couple of years ago. So both of those are candidates, but as I say, XS is probably where we're heading. So just talking, we've talked a bit about the data plane and what we need to do to hand those essences across and some of the elements there. I want to very briefly, just in 2 or 3 minutes, just talk you through the control plane, and specifically from the standards work we're considering. So I'm just going to put this picture up. I'm not going to dive into the next couple of pictures after this. They'll be in the slide deck, but they show you basically the thinking that we've currently got in the activity group on how we're going to handle this. But basically, the premises are such: a facility by definition, and the insistence of all of our end customers, has to be secure and self-contained. So it has its own control system, its own orchestration system. Typically if we're involved, that's video iPath. We have an ISO 4 registry, which registers all the devices in that system. We have ISO 5, which allows the connections to be made. That's all well and good. What we need to be able to do, if we actually want to share signals across the boundary, is securely make available just those signals and those flows which we are willing to share to a second campus. So we need to have what I've been calling a dynamic whitelist. So a list of resources which may be time bound, that list, that I'm willing to share with another facility for a time limited, typically, period. I advertise those across my wide area network, and those become available as resources to the other facility. That other facility is then able to ask for a connection from those sources, and obviously that's a symmetrical thing that can happen either way. And obviously bear in mind, I've got an example too here. We could have multiple facilities here sharing resources, and or indeed maybe an OB truck that's actually sharing resources with more than one at-home production for different producers. That's a very, very simplistic summary of a lot of detailed discussion we've been going through. As I say, I'll skip the next two slides, which you'll just see me whistle through here, which try and explain that in a bit more detail. Very happy to unpack them if someone wants to work. And because the work of the VSF hasn't finished yet, if you'd like to join the VSF, please do so. If you're already a member of the VSF, it would be great to be able to actually have you on board in the latter stages of this standard and try and get this best practice defined for the industry. Just coming back to that slide I showed you of a concept we've been working on, not only obviously in the control plane have we been working and are we really pushing hard to get the standards defined, but also we've been doing a lot of work within our video iPath system to do what I call secure federation. So API-based secure interfacing to allow one video iPath ecosystem on a campus or in infrastructure to actually securely share flows with another system, and vice versa. So that's an important element, and we've been doing that already and working through there. Just a couple of very quick things just to talk about from our perspective, just the second one, and I'll draw your attention to we're very much switch fabric agnostic. We've been working with all the key providers, strengths and a few weaknesses in a few places with different solutions, but we've actually got very familiar with the capabilities and the different product ranges that these switch providers have got, and our architects are very well briefed and able to help and guide you with what's the best choice to use for your projects in terms of scale, the way it handles PTP, the way we can do NAT, all of those other elements that are part of the switch ecosystem. It's also worth saying within video iPath, I talked about scale earlier on, that we've been on a journey as we've evolved video iPath over the last few years from a traditional master slave architecture, which a lot of deployments are still very, very comfortably based on, to a cluster environment, to a distributed environment. And all of this stuff about federation, sharing of resources becomes more and more enabled as we've done the changes and the architectural evolution that we've actually given video iPath. Also, another quick observation just in terms of the way that we're using our own equipment, our Virtuoso, our software-defined media node. You'll see it's got a whole lot of BNCs on there, but the point I'm trying to make with the accelerators that are actually shown in there, but the point I'm trying to make with this slide is actually a lot of deployments we've been doing probably only in the last 2 years, are starting both in the video and audio space to be just IP in, IP out. So we may be having to do a lot of audio processing, changing channel width, shuffling audio, doing gain, delay adjustments, all in the IP domain, or with the video, do JPEG XS compression, decompression, doing other manipulations that we need to do with the video. So we're truly seeing this, if you like, processing resource concept, which again can be shared and utilized across boundaries. So drawing into a close here, hopefully you've kind of got the taste of what we're working on, some of the standards work and the work we've been doing ourselves on enabling not only pristine facility capability and OB facility, but remote production, and now in the big world, distributed production, and giving true cost saving and flexibility advantages to the broadcasters and the end users of the systems. And goes without saying, we would love to talk with you next week or any time about the solutions that we've got within the Nevion ecosystem that actually supports both facility and wide area connectivity, and the combination of those two to come together to give you some of these advantages. Hopefully that's been useful. We've got, I think, about 4 minutes left for some questions. So I'm just going to have a last sip of my probably cold cup of tea now. If you're ever in the UK, if we're ever allowed to travel again, I'd love to see you and share a cup of tea with you. I can't make coffee, but I can make you a nice cup of tea. So thank you for sticking with me if you've stuck to the end. And we've got just 3 or 4 minutes for some questions. Cosimo, over to you. Are there any questions?
Yes, there was a question, actually, as a follow-up question from the previous one we got from Mr. Kais van Almengen, is asking if every switch supported or any particular brands or types. So basically, are there specific software options required depending on the brands and types? Can be answered when appropriate by you, of course, but what is your view about that?
Yeah, so what I would say is, we are, as you can see from this second point on this slide, vendor agnostic when it comes to switch fabric. So we've been working with Arista, Cisco, Mellanox, Juniper, and we have our own switch range as well. Different of those families of switches from those different vendors have different strengths in terms of scale, in terms of the way they handle certain elements. So, our solution architects within Nevion are in a very, very informed position to be able to guide you as to what are the best recommended switch fabrics. It may well be for the kind of applications you've got. Several of these vendors have got fabrics which would actually meet your requirements, but we have become very savvy in the work that we've been doing over the last couple of, 3 or 4 years now, working with these switch vendors very closely to develop specific features, make sure that they have the scale, both at the control plane, the PTP, in the PTB to PTP domain, as well as sheer data and essence connectivity. So there's a little bit of a horses for courses answer there, but if there's specific design requirements, speak to one of our solution architects who will be able to guide you through what our best choice of technologies or the range of choices that there are, because I know different broadcasters and different people have different religions when it comes to switch fabric as well. So we are very, very agnostic and can actually work with the best of breed between the different manufacturers, and we'd love to talk to you about that.
Another incoming question from John Paul Grau. Are there any mechanism to preserve the originating timestamp of each essence during processing? In his understanding, each process put a few timestamp and output, and it's hard to have an essence in sync at the end. Yes,
thank you. You've got back to my favorite topic just for the last minute here. So the change, one of the 1 year amendments that we've been making as a SMPTE drafting group to the -10 element is to allow an option where the origination time is propagated. And we've actually done that on some of the software releases in our Virtuoso platform already. So the concept is that you actually, if frame N has timestamp X, then when that frame N egresses that processing facility, be that a vision mixer, be that a graphics overlay, whatever is happening, then the same frame N has timestamp X associated with it, and the same with the audio processing. Now, not all vendors and not everyone is actually working to that yet, but the standard has been enhanced to kind of recommend and lead people into doing that. And my plea to the industry is that we actually do look at this. So let's honor origination timing as we actually propagate the system, propagate the production workflow with all the different media essences. It's a very important thing for us to do as an industry, and that's what we need to do to actually allow us to do that automatic reconciliation and all of the other stuff we want to do downstream to honor that timestamp. So speak to your vendors. I say we've been starting to do that in the last few months on equipment we've been pushing out. And you know, it's my hope for the industry that other people will follow suit and also do that. Any more?
No more question actually, and we arrived precise on time. It's 11 o'clock here in Oslo, and
Very good.
thank you guys for joining today's webinar, and thank you most of all to Andy Rayner, our Chief Technologist, for presenting this great topic. So we sincerely hope that you enjoyed the session, and we encourage you to register, as Andy said at the very beginning, for our next Friday session, for our next Friday webinar. We'll be sending you an email to invite you, but you can also go to the Nevion Alternative Broadcasting Show on the webpage and register using the link provided there. So we really sincerely hope you stay safe and you have a great weekend. And thank you again for joining this webinar today.
Thank you, and stay safe, everyone.